Hey everyone, in this lecture we're going to solve an exercise on process tree construction. This exercise states, given the following program, build the resulting process tree. Notice how here we have this program, we have the fork system call where we create a new child process. So now let us paste this code into a new file. We have created a new file with the name of processes.c and we have pasted this code. We can see that we have included the input and output library, also the standard library, and finally this library with the name uni.std. This is a library that declares operating system functions, including the fork function. That is why it is important for us to include this library in order to use this function. Okay, in this exercise we have to build the process tree that results from running this program. Take a look, what do we have in this program? Well, we have a for loop. This loop runs 3 times, and in each iteration we are calling the fork function. Remember that when we call fork, our program is duplicated. Now there are 2 processes executing the same code. The original process is called the parent, and the new one is called the child. Both processes continue from the line right after the fork. So, let us get started. Notice that initially, at the beginning, there is only one process, the main process, or program. In the first iteration of the loop, that is when I is equal to 0, fork is called. At this moment, process A creates a new child process, which we can call process B. This again happens during the iteration where I equals 0. At this point, there are 2 processes in the second iteration of the loop, that is, when I is equal to 1, both processes perform a fork, process A and process B, so that B creates a child process which we can call C, and A also creates a child process which we can call D. Notice that this happens during the iteration where I equals 1. Now there are 4 processes. In the third and final iteration, that is when I is equal to 2, all 4 processes perform a fork, that is A, B, D, and C. That is why A creates a new child process, which we can call E, B creates a new child process, which we can call G, D creates a new child process, which we can call H, and finally C also creates a new child process, which we can call F. Notice that all of this happens in the iteration where I equals 2, and keep in mind that this is the last iteration of the loop, because when I becomes 3, this condition is no longer satisfied, and we don't enter the body of the loop. So how many processes do we have in total? Well, we have a total of 8 processes. Now, notice we can verify this in the code if we print the PID of each process. In here, that is right before the program finishes, we print the PID. Then we shall see 8 outputs, right? 8 lines in the terminal. So, once we run this program, essentially each process will print its PID, its process identifier, before finishing. And we can get this using the getPID function. Now, notice that this main function ends without a return. Remember, however, that if a main function ends without a return, the compiler will automatically assume that it returns 0, that is, that it finishes correctly. Very well, let us now compile and run this program to check that we see 8 lines on the screen, that is, 8 processes printing their PID. First, we open the terminal and navigate to the same directory where our source code is located. In my case, I have to go to Documents, and then I have a folder called Programs, where I have this source code located. Notice that here, if we list the contents of this folder, of this directory, we can see that we have our program processes.c, which is this program in here. Therefore, let us compile and execute this program. We already know how to do this. With GCC, we can compile it. So let us call this program, for instance, just program. And here we need to indicate the source code, which is processes.c. We press the enter key. Now if we list, we can see how we have the executable, and we can execute this by simply writing a dot, a slash, and the name of our executable, which is here program. Now, once we run this, we should see 8 lines printed, meaning that 8 processes are printing their PID. So we run, we press the enter key, and here we can see that this is precisely what happens. We have 8 processes and each process is printing its PID. Very importantly, although we used simple identifiers like A, B, C, or D when building the process tree, internally the operating system identifies each process by its process ID, its PID, which are integer numbers. Very well, and with that we finish the solution to this exercise.